both false. However, this one is one-sided. If x is true, then y is true. If x is false, y can either be true or false. So in this case, x and y are equally true. If you recall the truth tables that we had, there in every proof we saw that the truth values match. They are equally true. Either they are both true or both false. However, in this case, y is at least as true as x. If x is true, then y is true. If x is false, then y can either be true or false. This situation is something like this. Okay, this is only for this is only an analogy. Okay, don't take it literally. I am talking about truth values. X and y are equally true. Here y is at least as true as x. It can be more true. Okay, so in that sense also we can consider these things. And I would suggest you prove this. It's not something very difficult. You can prove another law. X implies y and y implies x is logically equivalent to, although it looks very complicated, but you can prove it using truth table. I hope you can prove it. In this sense, this is one half of this. If we have both the implications from both sides, then we have if and only if. Okay, try to prove this one. Using truth tables. Now, okay, now we move forward. Now there is one more aspect of implication. In fact, sometimes we in fact use implication, although it is the least intuitive of all the constructs. We use implication more. Remember while we carried out this false proof, we were using implication. See? Implies. So this is a statement, this is another statement. So here this is an implication. This is hypothesis, this is conclusion. Again, this and this form another implication, where this is the hypothesis, this is the conclusion. So in mathematical proofs, what we really have is a sequence of implications. Now, while calculating with ordinary mathematical quantities, what we see is that something follows from something else by doing something. For example, here we have multiplied both sides of this equation by a, thereby we have got this. So there is a causal relation between hypothesis and conclusion, cause and effect. Okay, but in an implication, there need not be any causal relationship between x and y for the implication to make sense. I can write something like this. 2 implies wait, not like this. Let me write some absolute true statement. Okay, in this case, you see that there is actually no apparent causal relationship between hypothesis and conclusion. I mean, in the sense that how do you get